What's his name? Suleiman. Let me unplug my phone. Yeah, can you see the number system?
Yes, I can see it.
Okay, so let's go. Are you ready?
See, I'm ready.
Are you there?
Yes, I can hear you.
Okay, so read the question, answer. Let's go forward.
Okay, so I'm coming.
Are you there?
Which of the following pairs of elements has the greatest difference in electronegativity? A, Na and F. B, Na and Cl. C, Na and Br. D, Na and I.
Okay. So are you attempting? Are you attempting?
So I don't really know the answer for this one.
Hmm?
I don't know the answer for this.
Okay. So if you check through the textbook, the value of electronegativities for the different elements of the sodium is this for chlorine, for bromide. So when you're looking at the difference, so what's the difference between sodium and that of sodium and that of chlorine? So what's the difference between that of sodium and that of chlorine? So what's the difference between that of sodium and bromide? So if you check, you see that the one with the highest difference is between sodium and fluorine. And if you don't know, so you just look at which two, find that fluorine is more halogens. Chika, do you know what halogens are? Hello, Chika, are you there?
Yes, I know what halogens are. Hello. So I know what halogens are.
I don't know. Maybe you just get my number so that we'll talk later because I'm having a Zoom call.
Okay.
What's his name? Suleiman. Please get him, give him my complimentary card. Chika, are you there? Complimentary card.
Yeah, can you hear me? I said
Check
I know
inside
what
those.
halogens are. They are group 7 elements.
Good. So, which is the most reactive halogen? Bring that box. See that box.
Yes.
Okay. So those are halogens. Yeah. The four of them are halogens. So fluorine is a halogen, chlorine is one, bromine is one, iodine is one. So which is the most reactive halogen is fluorine. And you can
Fluorine.
simply see that. So yeah, you can see it in its electronegativity. You can see that it is the highest. This for fluorine, this for chlorine. So the difference in that electronegativity shows how two of them can easily react with one another. So you can see that all of them are all reacting with sodium. So the most reactive with sodium is fluorine. And that makes option A the right answer. Are you clear on that?
Yes, sir.
So let's move over to question number 17.
Number 17. A factor that is considered the most important when citing a chemical industry is, so I put nearest to raw materials.
Yeah, that's the most important. I hope you know that's the most important.
Yes, sir.
Why do we have oil and gas companies in the Niger Delta? It's because that's where the oil is, isn't it?
Yeah.
Then we'll have the cement factories closer to where we can get limestone. So closest to raw materials those are the most important. It's the most important factor considered in citing a chemical industry. Okay, so let's move forward.
So that solution I sent to you that my uncle did, he said that for
Yeah.
some questions at the back were not, it was not confirmed because the back answer was just writing option A, option B.
Okay.
Said I should ask you for them after.
Okay. That's 2000. Is it 2016, ma?
15.
Okay, 15.
Yes, sir.
Chemistry 215, Abi.
Yes, sir.
Okay, so possibly we look at that after this 2020. Or what do you
Okay,
think?
sir.
Okay.
Yes, sir.
So let's move forward.
Number 18. The boiling point of pentane is higher than that of propane because the intermolecular forces, I put the intermolecular forces in pentane are stronger than those of propane.
Okay. Yeah. So more forces because there are more atoms. coming together. I think that's a better answer to that. Okay, so let's move forward.
So wait, let me write this.
Okay. So the more carbon atoms, the more intermolecular interaction, the stronger the bond. So there are more pentane. You're talking about 5. Have you? Yeah, propane. You're talking about
Yes.
3 atom atoms. Propane is 3 atom atoms. Pentane is 5. So butane is 4. So the higher the carbon atoms number, the bigger the boiling point. Because the intermolecular forces holding those carbon will increase. So
Yes, sir, we can move on.
can move on back. Okay.
Yes, sir.
So let's look at question number 19.
Which of the following solids will not decompose on heating? Number. So please hold. So we can continue now.
Okay, we can continue.
Yes.
Did you jot down? Did you understand the explanation from the writer?
No, sir.
Are you seeing question 19?
Yes, I can see it.
So trioxocarbonates, they don't decompose on heating, except for lithium trioxocarbonate. So the trioxocarbonate falls. There's a special property for that. So ammonium chloride can decompose. Lithium trioxocarbonate 5 can, or potassium trioxocarbonate 4 do not. You can see there are various equations of decomposition when heated, unlike that of potassium trioxocarbonate. So this you can find under properties of under carbon and its compound, trioxocarbonate. You want to write down?
Yes, I've written that down.
So let's move over to question number 20.
So, but wait, you said trioxocarbonate cannot decompose on heat. What about lead 2? Is it not trioxocarbonate, lead 2 trioxocarbonate 4? Or is it because of the 2 there?
So these are lead 2 trioxocarbonate 5.
5.
This one is trioxocarbonate 4. So for alkaline metals, you understand, that is metals under group 1. Lead is not an alkaline metal. I hope you know that. So the trioxocarbonate
Yes.
for alkaline metal, those are the ones that don't.
What about sodium hydrogen trioxocarbonate? It's not an alkaline metal.
Yeah, sodium is an alkaline metal, but this is not just triazocarbonate 4. This sodium hydrogen triazocarbonate 4. Whereas this one is just pure triazocarbonate 4. So you can see in the write-up, it's clearly stated just for triazocarbonate 4, so not hydrogen triazocarbonate.
Okay, so I've got it. The following molecules have
That's the common. Give some
double covalent bonds between the two atoms, except I put 18. Sir, did you hear?
Yeah.
I said put 18.
Please come again. Okay. So the question says the following molecules have double covalent bonds between two atoms, except double covalent bond between two atoms. Yeah. So continue. Yeah. Bring it from outside. You're taking it down. Chika, did you see the explanation?
Yes, sir.
Yeah, so
So why is it not 18? Why is it bottom? Hello?
it's not the one that has have double covalent bonds. Which one does not have? If you draw the valence shells of the various what's it called? Various atoms that are involved, then you link up the electrons in the valence shells to make sure that they are stable. That means they have the octet configuration. They have 8 at the atomos shell. So which of them are having life? Which of them has double bond, double covalent bonds? So it's trying to tell us that 3 of them have double covalent bond, but 1 does not have. So which one is that? So let's say for oxygen. Oxygen has how many atoms and the valence shell? That's 6. You understand? So these are 6, these are 6. So how do they make up for 8? So 2 of them are gonna come out. These two here. So that when you now count, you have 1, 2, 3, 4, 5, 6, 7, 8 for each of them. So there's double covalent bond here. So the same thing happens for CO2. The same thing happens for 18 as well. But water don't do that. Yeah, thank you. So are you there?
So I said, where is entane's on?
This is for 18.
Okay. I'm jotting it down.
Okay. So once you are done jotting down, I'm going to sign off now. Then when I get home, I'll log back in by sharp 8 so that we can continue.
Okay, sir. Yes, so I've written this.
You've written them down.
Yes.
So I'm just closing now. Leave my office. And when I get home, I'll send you another link.
So did you clean water's own?
No, it will draw it down. You know, it went over, then I returned it back.
Okay.
So when I returned it, the water on was not there. But it's drawing it now on the screen. Are you looking at the screen?
Yes.
Help me with the charger. My phone cover.
Okay, so I've gotten it.
Yeah.
Thank you.
I'm gonna sign up now. I'll get home then.
So by 8.
Let's look at around 8. Yeah, 8:30. Not fast.
Is it physics?
No, stick chemistry. The physics I'm still working on it when I'm done.
It's finish chemistry.
Yeah.
Is it physics or finish?
We do chemistry. Okay, thank you.
So I said, is it finish chemistry?
No, it's chemistry that we'll do once I connect back. We'll continue with this chemistry. When we'll finish it, we'll try and finish it so that next meeting will be the remaining of the physics.
Okay, sir. All right, sir.